Today, in the temperature transmitter product line, we're going to talk about how transmitters work and compare them to some of the more commonly used thermistors and RTDs. We're going to talk about the difference between Class A and Class B RTDs and how they can make a difference or impact the overall transmitter accuracy. We'll then go into our NIST certification process and recertification services. Then we'll talk about some of the specialty configurations that we offer, which include ruggedized or potted transmitters, as well as high and low temp transmitters. We'll conclude the presentation by talking about how we back our products by our full 5-year warranty, which is the longest in the industry, and how our temperature transmitters fit into our overall temperature sensor product line before moving on to the Q&A portion of our webinar today. A temperature transmitter is a pretty simple device. It works by converting an input from a temperature sensor. In our case, we use a 100 ohm or 1000 ohm platinum RTD, and the transmitter board converts that resistive signal to a 4 to 20 current output back to your BMS or measurement system. Our boards are powered by a 24 volt DC power supply to deliver a 4 to 20 linear current output back to your system. Thermistors are more commonly used out in the controls industry, and transmitters provide a different type of output. Obviously, it's a current output versus a resistive output. And here's some of the differences or reasons why you would use a transmitter versus a thermistor. It's hard to say one is better or worse than the other. They're just different, and certain applications call for a current output, whereas others might be better suited for a resistive output. When using a transmitter, you can get a higher level of accuracy and a more stable output. That's not to say that thermistors are less accurate or less stable, but because a thermistor has a nonlinear resistance curve at the high ends and low ends of the temperature ranges, specifically if you get below 40 degrees C or above 125 degrees C, you're not going to get as stable or an accurate as an output as you would with a current transmitter. As such, the temp transmitters offer a wider operating temperature range. They also offer the ability to be recalibrated, retested, recertified. So for any critical applications, these units can be recalibrated or recertified down the road or periodically in the future so that your customer knows that the sensors and transmitters are always as accurate at any point down the road as they were on the day that they left our factory. When using a 4 to 20 current signal, you can transmit that signal over much longer distances than you can send a resistive signal. As the lead lengths or the transmission length increases with a resistive signal, the resistance increases, so that can affect the output. These current signals are also less susceptible to noise, whether that be other electrical noise from other electrical signals or from RF, wireless, or any other types of signals. And one of the main benefits of using a transmitter is it has universal or near universal system compatibility. Nearly every control system can accept a 4 to 20 input. We know that there are dozens, if not hundreds of different types of thermistors out there, all of them having different curves and different resistance values. And most controllers that accept a thermistor input are very specific. They can only accept one type, and that's it. So with the transmitter, you have near universal system compatibility. Our temperature transmitters use a 100 or 1000 ohm platinum RTD as the underlying base sensor in these units, and that's signified in the part numbers by using TT100 or TT1K. TT standing for temperature transmitter. The main difference between these two is that the 1000 ohm RTD is going to offer a higher level of resolution, and that simply means that it takes less of a change in temperature to move the ohm value 1 ohm in either direction, warmer or cooler. Both the 100 ohm and 1000 ohm RTDs have the same level of accuracy. They follow the same temperature curve and are available in the same types of outputs. Because the TT1K offers that higher level of resolution, we generally recommend using it when you have the choice or the option of picking which one. And also because of that higher level of resolution, the TT1K is available in all of our standard configurations, and there are a couple configurations of the TT100 that aren't available just due to that lower resolution. 4 to 20 milliamps is the standard output for all of our temperature transmitters, with 1 to 5 volt and 2 to 10 volt DC outputs available as options. All of these transmitter boards are calibrated to your specific temperature span that's requested when ordered. There's no standard or default temperature spans. So when you order a temp transmitter from us, you specify what range you want that to be calibrated to, and we set that up linear to the 4 to 20 milliamp output. These boards are designed to provide the highest level of accuracy in 100 degree F increments. So if you have the choice to pick your temperature span, we'd recommend you doing that in 100 degree increments. So either 0 to 100 degrees F, 0 to 200, minus 50 to plus 50, or any other span in which a 100 degree increment is available. That's going to get you the highest level of accuracy. The minimum span is 50 degrees F for all of our temperature transmitters. The combined accuracy between the sensor and transmitter, so the total accuracy of these devices, is going to be 1% or better. And like I mentioned a second ago, all of these are calibrated per order to the specific temperature span that you require for your application. These devices all use, for standard temperature ranges, Class A RTDs, and that's unique to ACI. We only use Class B RTDs in our high temp and low temp transmitters, whereas most of our competitors use Class B RTDs across all of their temperature transmitters. The Class A RTDs simply provide a higher level of accuracy and repeatability compared to Class B, but they have a narrower operating range. So we use those for all of the standard ones, but the high and low temps, we use our Class B RTDs. We have the ability to do NIST traceability and certification for all of our temperature transmitters. This is something that we're seeing more and more of in recent years, and we expect this trend to continue to grow going forward. And what we do when we NIST certify a temperature transmitter is that we pair an individual sensor to an individual transmitter, serialize that product, and test it in our NIST traceable testing chamber, and then provide documentation for each sensor that this unit on this date and this time passed our testing and falls within the stated tolerances of these temperature transmitters. So here's a short video that shows the NIST testing process. Here's Derek, who's the supervisor for our temperature transmitter department, preparing some sensors to go into the NIST chamber. And when we do this, every sensor is individually serialized so that its testing can be documented and traced. We also provide the specifications of the testing chambers that we use for these NIST certificates. So here we've got some OEM temperature transmitters that are going into the chamber, and our proprietary software is going to log the test results and determine whether they're within or without the stated accuracy specifications. Here's a sample of what the NIST certificate looks like that we provide with all of the temp transmitters, or the TTMs. I did forget to mention that a second ago. To include an NIST certificate with any of our temperature transmitters, that's what the M in the part number signifies. So it might be a bit hard to see here, but you can see the part number TTM1K. TT1K. And so that M in the part number is what signifies the NIST certificates. So this document would be provided with each sensor transmitter combination that is requested with an NIST certificate, has the TTM in the part number. We're seeing more and more critical applications that are requiring recertification of these temperature transmitters. So whether it's data centers, pharmaceutical manufacturing and storage, process manufacturing, power consumption, or any other critical applications, we have the ability and we're happy to do periodic retesting and recertification of any of our temperature transmitters. That involves sending the units back to us. We retest them in our NIST certification and provide updated documentation so your customer knows that at any point down the road, these sensors and transmitters are just as accurate and still fall within the tolerances as the day that they left our factory originally. Some of the specialty and custom configurations that we can do that you may not be familiar with include our ruggedized temperature transmitter boards. And here in the top right, you see what a standard temp transmitter board looks like. And we have the ability to ruggedize these by soldering the lead wires directly to the board instead of using terminal blocks, and then covering the entire board with epoxy to provide an advanced level of protection from moisture and chemicals and particulates. And these are available, these boards, these ruggedized, or also known as potted boards, are available in all of the standard TT or TTM configurations. As mentioned a few minutes ago, because temp transmitters provide a linear and stable output, we have the ability to do these in very high temp and low temp units, as low as minus 200 degrees C for our low temps and as high as 395 above 0 C for our high temps. These use Class B RTDs and all stainless steel fittings and components to meet the tolerances of those very high and low temperatures. Our freezer sensors come with a glycol bottle kit that acts as a thermal buffer to prevent your control system from going into alarm upon a shock of warm air from a freezer door or refrigerator door being opened. So if the door opens and this sensor without the glycol bottle were to get hit with a rush of 70-degree air, that could put the system into alarm. But however, you can fill these glycol bottles and put the sensor inside of that, and it acts as a buffer to slow the response time down so you can get an accurate trend of the long-term temperature changes due to system fluctuations. We have the ability to pre-fill this glycol bottle and pre-assemble the sensor into the bottle so that you can provide your customer with a complete package that's ready to install right out of the box. And we fill it with a food-grade quality glycol solution. We also have these 3-port kits and bottles that are available for any critical applications that require multiple redundancies of the temperature sensors. I wanted to talk for a minute about our calibration process. We use a proprietary calibration software system to calibrate all of our temperature transmitters, whether or not they're NIST certified. This delivers a higher level of accuracy and consistency than calibration by hand using multimeters can provide. And as a result of this process, our temp transmitters are not able to be calibrated in the field or recalibrated in the field. And that's is a good thing. So whether there's no mechanism for these to be calibrated in the field, either advertently or inadvertently, so there's no way that these sensors can be thrown off in the field or knocked out of calibration in the field. When we do the NIST certification process, we take the extra step of pairing a specific sensor to a specific transmitter, testing it in an NIST traceable chamber, and then documenting the results of that testing and providing that documentation with each individual sensor. Our temperature sensor, or our temperature transmitters, are just a part of our entire temperature sensor line, which includes thermistors, platinum and nickel RTDs, as well as the temperature transmitters that we've been talking about today. They're available in any and all applications, or for any and all applications, in any and all configurations that you can think of, including numerous ones that you don't see listed on the screen. We also have the ability to do OEM and custom configurations that you don't see here. So if there's something that you're looking for, whether it's private labeling, custom packaging, probe lengths, lead lengths, wire colors, and on down the road, we're happy to talk to you about that. So if there's something that you don't see on our website or don't see in our catalog, it doesn't mean that we can't do it. Please feel free to reach out to us at any time, and we're happy to talk to you about any specialty or custom applications that you have. All of our temperature transmitters are backed by our full 5-year warranty, and that's the longest in the industry. And they're manufactured in our ISO certified factory right here in Middleton, Wisconsin, where it's sunny and beautiful today. Every one of our temp transmitters is made in the USA. I mentioned a minute ago that we can work with a number of specialty and custom applications, and these are the guys to talk to help troubleshoot your specialty custom applications, answer any challenging questions, or help with any critical applications that you have. This is our tech support team, and combined they have over 75 years of experience, and they're happy to walk you through and help you select the best product that can get you and your customer the highest level of accuracy at any time. So feel free to reach out to these gentlemen at any time with any technical questions, application questions that you may have. With that, that concludes the presentation part of our webinar. I'll